Hello, and welcome to this lesson on solving linear systems algebraically. So in the previous two lessons, we learned about how to solve systems by graphing, and we found that happens when the solution of the system of equations is where the two lines intersect each other. So like that would be the solution, that point. The point is listed as an ordered pair, so like 3, 5. If that's the ordered pair, the coordinate where the two lines intersect, then that is the solution, where the x value is 3 and the y value is 5. The next lesson we learned about special systems, like what happens if our lines are parallel and they don't intersect. We saw that had no solution. And then we also saw what happens if our lines are overlapping. If it's the same line, we found out that had infinitely many solutions. But all of those were essentially solving by graphing, and solving by graphing is not the best way. What if, for example, if I draw an ugly little coordinate grid here, what happens if two lines intersect kind of in the middle of a box? We don't know exactly the ordered pair. We don't know exactly the x and y values that make that true. They can intersect in the middle of a box instead of intersecting at right one of the lattice points. So in this case, solving by graphing doesn't work for us. We need another method. And that's what we're going to teach you here today. So this is solving linear systems algebraically, using our solving equations stuff that we've learned about before in order to get the x and the y by itself. Okay? In case you didn't see the big huge pile of chicken nuggies there. So did you know, like if your mom sends you and your brother to McDonald's and she called ahead for a boatload of McNuggets, well, when you get there, they give you 3 small boxes and 2 large boxes of McNuggets, which is 70 total nuggets. Then they give your brother 1 small box and 3 large boxes of McNuggets, which is also 70. How many McNuggets are in the small and large boxes? This is an excellent example of a system of equations word problem. There's 2 unknowns. We don't know how many nuggies are in the small box, and we don't know how many nuggies are in the big box. But if we would set up a system of equations, like so, that's from these word problems, and if we could take this system of equations and solve and find the x and find the y, we would know how many are in each. And that's what we're going to learn how to do in this lesson. There is no new vocabulary, so let's do it. So in order to solve a system of equations, and by the way, we're learning a method called the elimination method. Okay, I choose this method because this is the method that most of my students prefer. After I show them a couple different ways, this is the way that they prefer. It's usually the least amount of work, and it's the most kind of straightforward. There's another method called the substitution method, which I will be showing in a later video, that typically is a little bit harder to do. Not always, but typically it's a little bit harder to do. You have to deal a lot more with fractions and decimals and stuff. So most students do prefer this method. So there's a couple qualifications that need to be met in order to solve a system of equations using the elimination method. First thing is the equations must be set up the same, meaning everything's lined up. So x over x, y over y, equal sign over equal sign, constant over constant. So they have to be set up exactly the same. This is already there. So step 1, check. The equations have to be set up the same. Variables have to be lined up. The second thing that must be true is, well, in each of these equations, we are going to add these 2 equations together. Now, what we'd like for one of the variables, either the x or the y, we'd like for one of the variables to have the same coefficient. That is the number in front of the variable. So here, I have a positive 2 and a negative 2. In front of my y's, I have a 3 and a 5. Now, this first problem is set up exactly how we want everything set up to use this elimination method. My equations are set up the same. My variables have the same number or my x's have the same number in front. And the third thing is, we want the signs of that number to be different. I have a positive 2 and a negative 2. And here's why we want all this to happen. If I would add these equations right now, like think of like up and down addition. What is 2x plus negative 2x? 2 plus negative 2 is 0. My x's essentially disappear. We have eliminated them. That's why this is called the elimination method. So when I add a positive 2x to a negative 2x, they cancel. Now I'm going to continue adding the rest of this equation, or the rest of these equations. So check this out. When I add a positive 3y and a positive 5y, we get 8y. When I add 11 plus 13, I'm just adding straight up and down. 11 plus 13 is 24. Now check out this new equation I have here. It does not have any x's in it. My x's canceled. I have 8y equals 24. That should be very simple to solve. All we need to do is divide by 8 on both sides, and we get y equals 3. That is the elimination method. I found y is 3. I found one of my variables. I know in my final answer, my ordered pair is going to be something, comma 3. I don't know what the x is yet, but I know the y coordinate is 3. Now, no matter what method you're using to solve your system of equations, the next step is the same. Once you've found one of your variables, in order to find the other one, we do a little bit of substitution, meaning I'm going to take this y value of 3, and I'm going to plug it into one of my equations for y. Now, I'm going to use, it doesn't really matter which equation. I'm going to actually change color as well. I'm going to use this top equation. So I'm going to write down the equation first, just to make sure we're clear on exactly what's happening. Now, I'm going to plug in 3 for y, because we've just learned that the y value is 3. That's what all this told us. Y is 3. So if I plug in a 3 here, my new equation looks like this. 2x plus 3 times 3. And that's an equation we can solve. I can find x here. I can multiply this together and get 9. Hopefully this looks familiar, and hopefully you know how to solve this. I can subtract 9 on both sides and get 2x equals 2. I can divide by 2 on both sides and get x equals 1. I have found the x value. And because of that, I now know my ordered pair. The solution to this system of equations is the point 1, 3. That is where these two lines intersect. Even though we don't see the lines, we didn't graph the lines, this is where they intersect. So this is the elimination. We eliminate one variable. We then solve the resulting equation to get the value of one of our variables. Once we know that, we plug them back into one of the original equations and find the other variable. And if you're thinking this is a lot of steps, you're right. It is a bunch of steps, but none of these steps should be that terribly hard. The hardest part is going to be, for us, eliminating that first variable. Now, this problem is very easy. Let's check out the next problem. So my goal is I would like to be able to add these equations together. But there's a problem. Watch what happens if I add my equations together right now. If I add 3x plus 3x, I would get 6x. If I add 2y plus 5y, I get 7y. And then 45 plus 72 is 117, I think. Yeah. So there's a problem. My x's and y's, none of them eliminated. I still have x, I still have y. I cannot solve this equation. So one of those things didn't work out. One of the qualifications I said in the last problem didn't work out. So my variables are lined up. Everything is lined up, nice and pretty and perfect. Check. Step 2. One of the variables needs to have the same coefficient, the number in front of the variable, and my x's do. Check. The third thing is we want these x's to have a different sign. That way I have a positive 3 and a negative 3. So the way we're going to do this is we can take one of our equations and multiply the entire thing by anything we want. So I'm going to take this top equation and multiply by what? What would I multiply by to make this go from a positive 3 to a negative 3? Well, we would multiply by negative 1. Now, I'm going to rewrite both equations over here. I have space, and so should you. So if I rewrite this equation, I'm now going to have negative 3x minus 2y. That is negative 1 times by the 3x. Negative 1 times by the 2y is now negative 2y equals negative 1 times by 45 is negative 45. I multiplied the entire equation by negative 1, not just this piece. If you multiply just this piece, you actually changed the problem. When you're dealing with equations, you always have to do everything to both sides. So I multiplied everything by negative 1 on both sides, and we're actually good. These two equations are equivalent. Now, when I write down my second equation, 3x plus 5y equals 72, I did not multiply that by negative 1. He stays the same. And the whole point of this was now to make, let me highlight, there we go, this. Now those variables will eliminate. I have a negative 3x, I have a positive 3x. They will cancel out. So if I add them together, I'm going to get a 0x. Cancel. When I add everything else, I'm going to get a 3y, that is negative 2 plus 5 is 3. And this is now going to be negative 45 plus 72 is 27. I can solve that equation pretty easily. If I divide by 3 on both sides, y equals 9. I have now found the y coordinate of my solution. Something comma 9. 9 is the y value. Now, in order to find the x value, I'm going to take that 9, that y value, and plug it into one of my original equations. I'm going to plug it into this bottom equation simply because, well, I've got space for it right here. I'm going to erase this. So I'm just going to plug the 9 in right there. So that becomes 5 times 9. There we go. And we're going to solve for x. This is 45 equals 72. And I solve. I'm going to subtract 45 on both sides. 3x equals, that should be 27. Because that's the same math I just did here. 45 minus 72. And then divide by 3 on both sides. And x equals 9. So I found the solution is the point 9, 9. Now, let's say we did all this work, and I want to know, is this the correct solution? Is this answer right? Did I do all this work correctly? Here's how you would tell. Now, I'm going to erase all this work, so if you want to keep any of this work here, you might want to pause the video. All right. Everybody else, we're going to erase all of this. I'm going to keep my solution, delete. To check your answer, we've actually done this before. All you do is you're going to plug in the 9 for x, the 9 for y in both equations. And if everything works out right, this math should work. So if I plug it in here, so 3 times my x value plus 2 times my y value equals 45. Is 27 plus 18 equal to 45? Does that math work out? 27 plus 18 is check. So when I plugged in 9 for x and 9 for y, this first equation worked out. The math was good. Okay, if I do the same thing in the second equation, 3 times 9 plus 5 times my y value equals 72, I get 27 plus 45 equals 72. Does that math work out? Is 27 plus 45 equal to 72? Check. Okay. So that's how you check the solution to one of your systems of equations. You plug in the x for the x, the y for the y, in both equations, and see if they both work. Now, a harder example. So if you're looking at this, first off, my equations are still set up. X's over x's, y's over y's, equals, constants, everything's lined up perfectly. So that's not a problem yet. That will become a problem eventually, but not yet. Okay, we're kind of building up to that. The problem here is my x's don't have the same number in front. My y's don't have the same number in front. So I can't even eliminate yet. So now you have choices. We need to make either the x's have the same number in front or the y's have the same number in front. So what you're thinking of is a common multiple. What is the least common multiple of 3 and 12? The least common multiple of 3 and 12 is 12. Now, you actually have, if you're using this blue calculator, and even on the fancy graphing calculator, there's a least common multiple feature in here. So if I do least common multiple of 3, I think there's a comma, 3 comma 12, it says the answer is 12. So if I would make both of these 12 x's, they would eliminate. And I could do that. I would multiply the top one by 4 and the bottom one by nothing. I don't have to multiply the bottom equation by anything. What about if I wanted the y's to eliminate? Because sometimes you do. In fact, I'm going to do it in this problem. If I wanted my y's to eliminate, what's the least common multiple of 3 and 5? The least common multiple of 3 and 5 is 15y. And math, least common multiple of 3, comma, so I did second period, there's your comma, 3 and 5 is 15. So I'm going to make my y's eliminate. I'm going to make that happen. I'm going to make them both become a 15y. And if you don't know how you do that least common multiple in your head, you're looking for your oh man, wasn't supposed to be on eraser. You're looking at your times tables. In the times tables of 3, 3, 6, 9, 12, 15, 18, 21, whatever. And the times tables of 5, 5, 10, 15, 20, you're looking for the smallest one they have in common, which is 15. Okay, that's the least common multiple. And that's very helpful if you are pretty good at your times tables. So now I've decided I want to make my y's eliminate here. So how do I make this happen? Well, to make my bottom equation, to make this negative 5y become a 15y, I'm going to multiply by 3. Because if I multiply by 3, it'll work out. Let me check this out. If I multiply the entire thing by 3, I'm multiplying everything. So 12x times by 3 is 36x. Negative 5 times by 3 is a negative 15y. And 33 times by 3 is 99. So I multiplied every single piece by 3. Up top, to make this 3y here become a 15y, I'm going to multiply the entire equation times by 5, because 3 times 5 is 15. Now I have to do it to the entire equation, so I'm going to get a negative 15y, that is 5 times by negative 3. I'm going to get a my bad. That's supposed to be an x. That's negative, or 5 times by negative 3x is negative 15x. There we go. Now, 5 times by this 3y is a positive 15y. And then 5 times by negative 3 is negative 15. Now, look at my new equations. My y's will eliminate. I have a positive 15y and a negative 15y. If these were both the same sign, if they were both positive, all I'd have to do is change one of these things to a negative. If I multiply by negative 5, it would have changed the sign. Okay? So now we can eliminate. My y's will eliminate. It's the same number with a different coefficient, or with a different sign, so they cancel out. Now the rest of the problem is very much what you've seen before. So we're going to add negative 15 plus 36 should be 21x. And then negative 15 plus 99 is 84. When I divide both sides by 21, I'm just solving this equation now. I'm getting x by itself. I bet you that's 4. Divide by 21 is 4. So I now know the x-coordinate of this system of equations, of the solution, is 4. Now, I have to find the y-coordinate, the y value. So what we do is we're going to take this 4 and we're going to plug it into one of our original equations. In fact, I could plug it into any of these 4, any of the equations that still has an x and a y. And by giving you a choice, you can choose the one that looks easiest to you. I'll be honest, I'm not going to choose this bottom one here because those numbers are bigger. I'm going to choose this one right here because those numbers are smaller. So I'm going to take this equation here and I'm going to plug in a 4 for the x value. So it becomes negative 3 times by 4, that's my x value, plus 3y equals negative 3. And now when I solve this equation for y, I will find my y-coordinate. So negative 12 plus 3y equals negative 3. Add 12 to both sides. 3y equals 9. Divide by 3, y equals 3. So my solution is the point 4, 3. So this is almost the most work you're going to have to do in one of these problems. We had to make the y's eliminate. So we had to multiply both equations by something to make them have the same coefficient, but different signs. We then eliminated, and then we plugged in. Now all of this work down here, this will be the same no matter what method you do. That will be the same in every single problem. Okay. The only thing that would have been harder is if these two equations weren't completely set up the same. If the x's and the y's weren't lined up, that's the only additional work you'd have to do in one of these problems. But before we get there, I want to give you a chance to try some as well. So here is letter D. If you could pause the video and try this problem right now and eliminate, I'll give you a hint. Your y's right now are ready to eliminate. If you look at these equations, x's are lined up, y's are lined up, equals, constants, everything. Your y's have the same number in front but different signs. So go ahead and solve this equation right now. When you're ready to continue, hit play on the video, and then we'll go through it together. All right, so if you did just that, your y's do eliminate. Negative 4y plus 4y is 0y. You have 0 y's left. Over here, 5x plus a negative 3x is 2x. And positive 34 minus 30, or plus a negative 30, is 4. Solve the equation by dividing by 2. X equals 2. I have my x value. To find the y value, I'm going to take that 2 and I'm going to plug it into one of my equations for x. I'm going to pick the top equation because there's less negatives. I don't like to deal with negatives if I don't have to. So I'm going to use the top equation. So I'm going to take this guy here. I'm going to rewrite them for you. 5x minus 4y equals 34. I'm going to plug in 2 for the x. equals 34, and then we solve. That's a 10, and this should be just normal solving equation junk. Subtract 10 on both sides to cancel out the positive 10. Divide by -4 on both sides, and y equals -6. -6. That is our solution. So these two lines will intersect at the point 2, -6. Okay, letter E. Now these are just like the second example we did together earlier. They are almost set up for elimination. There is a problem. The problem I'll tell you right now, or how about this? If you don't want to hear the problem, pause the video and start the problem. If you do want to hear the problem here, it's my x's. My x's are almost ready to eliminate. They have the same number in front, the equations are lined up. The problem is these are both the same sign. So you'll need to make one of them a positive and one of them a negative, and then you can eliminate. So now everybody else, go ahead and pause the video. When you're ready to continue, hit play, and we'll go through it together. All right, so the way I would do this is I would multiply the top equation by -1. If you chose to multiply the bottom equation by -1, there's absolutely nothing wrong with that at all. I chose the top, I don't know, just because really. So when I'm going to multiply each of these by -1, I'm going to get -4x. No, I lied already. I'm wrong. Let's try it again. Positive 4x, because -1 times by -4 is positive 4, plus y equals a positive 36. It changes the sign of every single piece when you multiply by -1. Each of these was negative, now they're positive. My bottom equation stays exactly the same. I'm not doing a darn thing because that's what makes my x's eliminate. -3y equals -28, and now we go. So my x's will eliminate. My y's will become a -2y. I took 1 plus -3 is -2. My constants, 36 minus 28, or 36 plus a -28 is 8. So we divide by -2 on both sides. Y equals -4. Very nice. So now we have, now we have the y coordinate of our solution. It's something comma -4. To find the x coordinate, we're going to take that -4 and plug it into one of our equations. There's negatives everywhere, so this problem doesn't really matter which equation you pick. I mean, there's not one that I see that'd be easier than the other, so I'm just going to plug it into the bottom one because I've got space right here. So I'm going to plug in -4 for y, like this. And now, when I solve the equation, we'll find our x value. So -4x plus 12, that is -3 times -4 is a positive 12, equals -28. I subtract 12 on both sides. 4x equals -40. Divide by -4, divide by -4x equals a positive 10. So my solution is the point 10, -4. Letter F. If you don't want any hints, pause the video and try this problem right now. If you do want a little hint, listen for another couple seconds. So, hints, if you wanted your x's to eliminate, the least common multiple of the 4 and the 8 is what? The smallest number in both of their times tables is 8. So you'd have to make both of your x's become an 8x if you wanted your x's to eliminate. If you wanted your y's to eliminate, the least common multiple of 1 and 5 is 5. So you'd have to make both of these become a 5y to make your y's eliminate. And then the only other thing you'd have to worry about is making sure one of them is a positive and one of them is a negative. So either a positive 8 and a negative 8 or a positive 5 and a negative 5. Okay, everybody else, do it now. All right, so I'm going to make my y's eliminate. I don't know, I just picked one. It doesn't really matter. It's the same amount of work. If I made my x's eliminate, here, I'll show. I'm not going to do the whole thing. To make your x's eliminate, you'd multiply this top equation times by -2. That would make this become a -8x, and then this -8x and this positive 8x would eliminate, and the problem would be good. Okay, to make the y's eliminate, I'm going to multiply the whole thing times by a -5. That makes this become a -5y, and then my y's will eliminate. Okay, so I'm just choosing to multiply by a -5. It doesn't really matter which one you picked. We should still end up with the same answer. So that would become a -20x minus 5y equals a positive 150. The bottom equation would stay exactly the same because we want a positive 5y. That way the y's will cancel out. So everything's just going to stay exactly the same. And now we eliminate. My y's will eliminate here. They're going to cancel out. They're gone. My x's, let's see. That's -12x, and then that is 120. That's fairly easy to solve. Divide by -12 on both sides, and x equals -10. I now have the x coordinate for my solution. To get the y coordinate, I'm going to take this x of -10 and plug it into one of my equations. I'm just going to pick the bottom one because he's right here, and let's solve it. So if I plug in was x is -10. And then I solve this, that will tell me my y value. That is a -80 plus 5y equals -30. I'm going to add 80 on both sides. Yes, I'm going quick because, well, it's just solving an equation, and you should hopefully be familiar with that by now. Y equals 10. So my solution is when x is a -10 and y is a positive 10, that is where these two lines will intersect. So what does it take to eliminate one variable in a system of equations? Kind of what qualifications are needed? Well, they have to have, the equations have to be lined up the same. Everything has to be lined up. X's over X's, Y's over Y's, and they don't even have to be in standard form. Everything we saw was in standard form, but check this out. If I had y equals 3x minus 5, or 2y, and 5y equals -3x plus 8, I could use the elimination method right now. I could go, hey, look, my y's are lined up, and my x's, and my equals, and my everything, and I could eliminate right now. My x's would cancel out, and I would get no x's, and 7y equals 3, and I mean, that answer is not a pretty answer. If I divide by 7, I get y equals 3/7. That happens. It's okay to get fractions and decimals for answers, but I mean, so I just made these two up off the top of my head. It didn't come out to a nice, pretty answer. But it still works. So they have to be lined up. Second thing that has to be true is you want the number in front of one of the variables, the coefficient, to be the same. Either your x's or your y's. And you want that number, that coefficient, to have a different sign. You want one positive and one negative. Those are the things needed in order to do the elimination method. Now, some special systems. Now, if you look here, these equations are set up side by side. And even if I rewrite them right now, -3x plus y equals 2, you see they are not set up and down from each other. They are not, like, x's are not lined up with x's and y's with y's, and it's not pretty. So we have to do a little bit of rearranging ourselves. And it's not too bad. Like here, to make this equation look like all the other ones we did up above, we want the x's and y's to be on one side. So if I move this 3x over to the other side of the equation, we're good. We're done. And I can do that simply by just subtracting 3x on both sides. And I would get negative 3x plus y equals 2. I subtracted 3x on this side. He's gone. So I have a negative 3x. Here's my positive y equals 2. Now, check out those two equations. They are identical, meaning these two lines are the same line. Now, we saw in the previous lesson, if the two equations are the exact same equation, what happened when we graphed it? What happened with our solution? When they were the exact same equation, our lines were overlapping. It was the same line, and we had infinitely many solutions. This is the same. These two lines have infinitely many solutions. These two lines are the same line, and I can show this another way. This equation is slope-intercept form, so I could graph this if I needed to. My other equation, this one here, to make it slope-intercept form, I'm going to add 3x to both sides. Y equals 3x plus 2. There, check them out. It's the same exact equation in slope-intercept form. So these two are the exact same line. They will have infinitely many solutions. So that sort of stuff can happen with systems of equations as well. A lot of times they're going to hide the fact that they're the same equation. Look, they don't look the same originally, but when you put them in the same form, either when you have the x's and y's lined up and everything's good, we can see that they are the same equation. Infinitely many solutions. By the way, what infinitely many solutions look like, if maybe you didn't notice this was infinitely many solutions and you didn't notice it was the same line. Watch what happens when I try to eliminate this. So let's just play pretend. I'm gonna keep going here. I go, well, my x's have the same number in front, but it's the same sign, so I'm gonna multiply this top equation times by -1. That way this becomes a negative 3x. Now, little shortcut for you. I haven't shown this yet. You can just change the sign. If all you're doing is multiplying by -1, just change your signs right there in the equation. It'll save you a little bit of time. All right, now, if I eliminate, my y, or my x's here, will eliminate. A negative 3x and a positive 3x is 0x. They eliminate. My y's, negative y and a positive y, when I add them together, I get 0 y's. They eliminate. My 2's, -2 plus +2, they technically eliminate. I get the equation 0 equals 0. And this is true. Like we've solved equations before. When you solve an equation, like if you solved an equation like 3x plus 5 equals 3x plus 5, and you saw that they're the same, and you like eliminated junk here, and you subtracted 3x on both sides, and you got 5 equals 5, and we said, hey, that's true. That was infinitely many solutions, or all real numbers. This is the same thing. Because this is true, this system of equations will always be true. Every single thing is an answer because there's infinitely many solutions. Okay? Letter B. Now, looking at these two equations, they're side by side. We could write them up and down. X minus 2y equals 10. So I just rewrote him under there. Okay? My equations are lined up. X's over x's, y's over y's, equals, constants, all that's good. They do not have the same number in front of one of the variables. The coefficients are different. So 6 and 2, 3 and 1, that's a 1 there. Now I could make them the same if I multiplied one of these equations by, or not one, if I multiplied the bottom equation times by 3. But actually, I don't want to multiply by 3. If I multiplied by 3, this would become a negative 6. That won't make anything eliminate. I would multiply by a negative 3. So now negative 3 times by negative 2 is a positive 6, and my y's will eliminate. So let's do that. So I'm going to have, in my top equation, I'm not multiplying by anything. It's going to stay the same. So 3x minus 6y equals 36. Bottom equation is going to become a negative 3x, that's negative 3 times by the x, plus 6y, that's negative 3 times by negative 2, and a negative 30, that was negative 3 times by 10. I multiplied everything by negative 3. Now when we add our equations together, check this out. My x's eliminate. My y's eliminate. My coefficients don't eliminate. In fact, I get 0 equals 6. Does 0 equal 6? Not where I live. Before, if we were solving an equation, so 3x plus 2 equals 3x minus 9. And when we solved and we subtracted 3x, this is a long time ago, like way back in the very first unit we learned, and these eliminated and those canceled out, and you got 2 equals negative 9. We would have said this problem has no solution because this is not true and will never be true. Well, when you're solving a system of equations and your x's and y's eliminate and you get something that's not true, this problem still has no solution. Now we can extrapolate a little bit. We can use our brains here a little bit, and I can say, hey, what does the graph of this system of equations look like? And hopefully you're going, wait, for there to be no solution, these lines never intersect each other, so these two lines are parallel. Maybe not exactly like this. They might have a negative slope or something, but the lines are parallel because they never intersect. There is no solution. Okay. Now, you're not always going to know when there's going to be a special solution. Like this set of questions says, find the special solution. Okay. But they won't always do that. But let's go ahead and have you folks solve this one first. So go ahead and pause the video, solve this system of equations, please. When you're ready to continue, hit play, and we'll go through it together. All right, so in order to do this, you had to do a little bit of rewriting. Because if I set up my equation, if I just rewrite this one down here, y equals negative 2x minus 7, and even if I line up my equal signs, you see stuff's not lined up properly. Now I can fix that if I would have started by adding 2x to both sides and got 2x plus y equals negative 7, then everything lines up. 2x plus y equals negative 7. Okay, so sometimes a little rewrite is needed so that your x's and your y's line up. Okay, we are at that stage where we're confident we're able to do that ability now. Okay, we would like to add these equations together, but my x's don't have the same coefficient, my y's don't have the same coefficient, although hopefully you saw what to multiply by. You would multiply your bottom equation times by a negative 2. Multiplying by negative 2 makes this become a negative 4, and my x's will cancel. Okay, so let's do that. I'm going to zoom out. Well, I don't have a lot of scroll space. Sometimes if you don't have a lot of space here off to the side to work, sometimes you can just rewrite the equations like down below if you got more space up and down than sideways. So I'm going to do that here because I don't have a lot of space off to the side. Ooh, stop glitching. There we go. So I'm going to rewrite both of these equations down here with this one being multiplied by negative 2. So it is negative 4x minus 2y equals positive 14. Okay, so that was this equation multiplied by -2. 2x times by -2 is -4. 1 times by -2 is -2. And -7 times by -2 is a positive 14. Now, this other equation, I'm just going to copy down. 4x plus 2y equals -6. So now my x's will eliminate. See, positive 4 and -4x, they cancel out. You get a 0. My y's actually eliminate as well. We get a 0. My constants do not eliminate. 14 minus 6, or 14 plus a -6, should give us 8. And I got now 0 equals 8, which is not true. So this system of equations has no solution. These two lines are parallel. Even though we don't know what they look like, I know they're parallel. I know they never intersect because both my variables canceled out, and we're left with something that is not true. We have no solution. Okay, I'm looking at my two equations. Stuff's not lined up very well. Like, x is over here by himself on this equal sign. I've got, in the other equation, I've got x's and y's on the same side. So I'm going to fix this first equation. I'm going to add 2y to each side. So now my x's and y's are on each side of the equal, on the same side of the equal sign. That's what we want in order to eliminate. Now, actually, to save a little space off to the side, oopsie, I didn't mean to erase all of that. To save a little space off to the side, instead of rewriting, there we go. I'm going to actually rewrite this equation down there. So we've got -3x minus 6y equals -24. So everything is still lined up. I now have more space off to the side, so I can like rewrite the equations if I need to. All right, so I'm looking. I mean, the common multiple of 1 and 3 is 3. So if I multiply this top equation by 3, my x's will eliminate. So let's do that. I'm going to multiply my top equation times by 3, and I'm choosing a positive 3 because that would make this become a positive 3x, and that will cancel with this -3x. The signs will already different. So in doing that, I get a 3x plus 6y equals 24, and on the bottom, it stays the same. -3x minus 6y equals -24. And look at this. Same number, different signs, cancel. Same number, different signs, cancel. Same number, different signs, cancel. I got 0 equals 0, which is true. These two equations are the same equation. This has infinitely many solutions. So these two equations are overlapping. They are the same equation. If I would multiply this bottom equation by -1 right now, or this top one by -1, they would be identical. They'd have the same signs, the same numbers, the same everything. These two lines are overlapping. This has infinitely many solutions. All right, we've got 2 problems left. Now, as I was saying before, some equations, you don't know if there's going to be a special solution or not, like this one. It just says, solve the system of equations if possible, meaning you try to solve it. You might get an answer like x equals 5 and y equals 3, like a point like we had earlier, or you might get one of these special solutions and you just don't know. Okay, so I'd like you to pause the video and I'd like you to try this right now. You should hopefully have the ability and the confidence to do this problem on your own from beginning to end. So pause the video and do it. When you're ready to continue, hit play and we'll go through it together. All right, here. So I'm looking at my 2 equations. They are not lined up the same, so they're not set up the same. x's and y's are on the same side, x's and y's are on different sides. I'm going to fix that, but I'm going to move this x piece over here. So I like, when I'm doing systems of equations, I like this format. I like it when the x's and y's are on the same side. That's called standard form. So in order to do that, I'm just going to subtract 1/2 x on both sides. And the equation becomes negative 1/2 x plus 2y equals 7. And then I'm going to take him and line him up. So it was negative 1/2 x plus 2y equals 7. Okay, so now everything's lined up. X's over x's, y's equals constants, all that's good. Now in order to make these eliminate, this is a little hairy right here. Like 1 and negative 1/2. It's actually not too bad, but I'm looking at these y's. 4 and 2, I can do that pretty easily. If I have a 4 and a 2, all I'd need to do is make this one become a negative 4. Like if I multiply this bottom equation times by negative 2, this become a negative 4, and my y's will eliminate. Okay, so let's do that. Let's multiply that bottom equation times by negative 2, and the top equation stays the same. So x plus 4y equals 18. What is negative 2 times by negative 1/2? Why, it's positive 1. Minus 4y equals negative 14. Okay, so we have a positive 1x, a negative 4y, and a negative 14. Now when we eliminate, when we add our equations together, x plus x is not 0. I can see some folks making that mistake thinking they're going to eliminate, but they have the same sign. That's 1 plus 1 is 2x. Y's do eliminate, they cancel. And my coefficients, it's going to get a positive 4. So because my x's and y's did not both cancel out, this problem can be solved. And we just kind of keep going. Divide by 2, x equals 2. I know that is going to be the x value for my solution. Now, which of these equations do I want to plug 2 into for the x? I could plug it in here, I could plug it in here, I could plug it in technically here. It makes no difference. I can plug in any of these that has an x and a y in it. So you pick one. I'm looking to see if there's one that looks any easier than the others. I don't know, not really, not too much. So, I mean, I guess I'm going to pick, here, I'll use green. I'm going to pick this equation here. It's kind of like the most kind of straightforward equation. There's no fractions, there's no negatives. So I'm going to pick him. So I'm going to plug in 2 for x. And then solve. I'm going to subtract 2 on both sides. 4y equals 16. Divide by 4, and y equals 4. And there's my solution, the point 2, 4. So these two lines intersect at that point 2, 4. All right. We are on the last question for the lesson. Come on, zoom. There we go. So go ahead and pause the video, solve the system of equations if possible. When you're ready to continue, hit play, and we'll go through it together. All right. Now, these equations actually are already set up for elimination. Check it out. I copied him down. My x's are lined up, my y's are lined up, my constants are lined up, everything's lined up. So all I need to do now is, well, make them have the same numbers with different signs. Like here, 1x, 1x. If I would make this a -1 or that one a -1, they would eliminate. So I'm going to do that. I'm going to multiply this bottom equation times by -1 to make my x's eliminate. So if I rewrite both equations, top one stays the same. Bottom one gives a negative x equals a positive 2y plus 6. And now I eliminate. X plus negative x is 0. It eliminates. It cancels out. Negative y plus 2y is 1y. Positive 1y. And 2 plus 6 is 8. Solve the equation, subtract 8 on both sides, and y equals negative 8. That is the y value of my solution. To find the x value, I'm going to take that negative 8 and plug him in. I'm plugging him in right here, just because I have space to work. So that is x equals negative 2 times by negative 8 minus 6. X equals positive 16 minus 6. X equals 10. And there we have it. Summary. Well, which method of solving equations do you like best? Do you like solving by graphing best? Or do you like solving by this elimination best? That's really a personal opinion. I personally like solving by graphing if a graph is provided, because typically that's a lot quicker and easier. You just look for where the lines intersect, and that's your solution. But if they don't intersect at a nice pretty point, then solving by elimination is your backup method. So I like solving by graphing first, and then after that, I like solving by elimination. Thank you so much for watching, and until next time, toodles.